All right, welcome everybody to the first Construction Tech of 2022, featuring none other than co-host Kevin Brennan presenting about dense packed cellulose insulation. So with that, I'm going to hand it off to the other co-hosts to get it going.
Happy New Year. Welcome everyone. As Zach said, we are kicking off 2022 with a bang because we're not bringing on one of the big guys here. We're bringing on Kevin to talk to you about something that's dear to him and also dear to us when we're looking not at only passive house, but low embodied carbon products. So it's great to have it because you know he's going to bring the technical, the technique, and the technology. And here we get started. I'm Sean Sainham. We're happy to be here from Vancouver, BC, where I'm going to be all plugged in to listening to all about cellulose.
Excellent, excellent. Thank you, Sean. Welcome, everybody. Happy New Year. It is wonderful to see you all again. Hope your holidays were bright. Your resolutions are firmly in place. And get ready tonight to celebrate the celebrated king of cellulose with us. The man who needs no introduction, Kevin Brennan, our friend and co-host, is here to help us understand the do's, the don'ts, and the whys and the why nots. So I am excited and hoping that during the Q&A, you guys will give us lots of questions for Kevin to field, and we'll be watching your questions in the chat and asking you to unmute yourselves in the after hour. And with that, I'll hand it off to Mark. Thanks.
All right. Thank you, Zach. Thank you, Sean. Thank you, Shannon. I had the pleasure of meeting Kevin Brennan pretty much exactly 10 years ago, give or take years, right? And we had a run through of this presentation. And Kevin switches it up every time. As it turns out, you're going to want to get your notebook out and your camera ready because this is about a 4-hour presentation. And we're going to be taking you through the whole process. Don't believe what I say. That's why there's better hosts on this program. So my name is Mark Willey. I do love what Kevin does. I do think that it is important to take photos and notes. I do think it's important to share what you learn with the marketplace via your social accounts. And I do think it's important to ask more questions. So anytime you have a question, put a queue up and let us know. We will get back to the questions after the presentation, but I wanted to mix things up tonight. I don't feel ready to give the introduction, so I'm passing the microphone to Michael Ingwe to give the introduction to Kevin tonight.
All right, thanks, Mark. And I am Michael Ingwe from Baxter Architects, also with the Accelerator, working with the team here. And I am really excited and proud to be introducing Kevin Brennan, who I've known for quite some time now. I met Kevin when he saved my ass on one of my first passive house projects. He's then since really helped our office as well as a lot of other companies create this repeatable approach that I like to take credit for. He's taught most of the contractors, actually all the contractors who I work with, multiple subcontractors, and really is such a positive teacher on the site that everyone becomes addicted to passive house. Everyone wants to hear what he says. They want to listen to him. And I have to say, it's been a pleasure to work with him. I definitely have benefited pretty heavily, and I'm looking forward to having him share even more of his knowledge with everyone today. I really was going to joke, but I decided I wouldn't today. Just be nice to Kevin. Go for it, Kevin.
Thanks, Mike. Shannon, Mark, Sean, thanks for the kind introductions. Happy New Year, everyone. Thank you for turning out to Construction Tech. I'm excited to present something that has been a staple in my career, and hope that everyone can gain some insight and learn some things. And I'm happy to answer some questions that go along. I'm going to share my screen here. I'm Kevin Brennan from Brennan Insulation and Air Tightness, and who I am and what I am, you guys will know. But one of the things I take great pride in is being a certified passive house tradesperson. I look at being a passive house tradesperson as the top of the pyramid of the skills needed in construction. And one of those bases of skills was taught to me very early on in my career. And it's something I take great pride in, and innovating and trying to get to the top of my my career chain. This is my history. You guys can get some further insight on listening to the wonderful podcast that that Zach put on for me. And it was a great show. So in 2002, I was at the College of Staten Island, and I wanted to get the hell out of here. So I figured out a way how to get a study abroad program to the University of Newcastle in Australia. I love the culture. I love the place. I had a great experience. And when I was there, I noticed that there was just a kind of like a greater appreciation for the work and hands that were out there. And when I came back and I just took a step back, I realized maybe I wanted to get into the trades. So at that time, right after I came back, and I had a decent amount of debt when I came back because I took one too many trips and had too much fun, I said, college couldn't hold off. I'm going to take a job I wound up finding myself working for a weatherization agency. And if anyone's not familiar with weatherization, it's a nonprofit, kind of like federally funded program throughout the US that fixes people's buildings by using air sealing and insulation. It's kind of like was a driver of building science. The next step in that training program that I was involved in at Northfield, through my jobs as being an air sealing installer to the post inspector to the energy auditor, was taking the BPI training. BPI training was great, opened up the world of building science to me, really got my curiosity going of how buildings are built, why they're built, what are the mistakes that they have, how do you solve those problems. And speaking of solving problems, in 2006, I was the very lucky recipient of a phone call and results on a test that allow me to have the opportunity to serve the city of New York as a New York City fireman. So especially after these past few days with the deadly fire in the Bronx, you really appreciate that you get the opportunity to go out and help people on their worst day. I work in the Bronx, and luckily my firehouse wasn't there, but if we were there, we would have done our best to help those people at that time. But some of those problems in that building are kind of air sealing and insulation related. Not to really nerd out on that, but the compartmentalization of that building probably wasn't where it needed to be. So I've been a fireman since 2006. I've been involved in Passive House through working for the Association for Energy Affordability and other places, being a trainer and teaching people about Passive House. And in that process of teaching people, I had the opportunity to talk my way on to actual passive house projects like Mike's and say, hey, we can do dense packed cellulose. That's something it's a core competency of ours. And next thing you know, I opened up a business with my brother, Brennan Insulation and Air Tightness. I'm going since 2012. And I've had the great pleasure of being a part of this lovely team for the Passive House Accelerator in 2018. And this timeline is going to continue on. But while I was preparing for this lovely presentation, I went back in time in Google Photos and went through all my pictures of cellulose and the history that I have. So I'm going to share some of those early pictures that I have. So this is a lovely picture of my good friend Pete Vento and my crew leader at Northfield. There's a weatherization department. That is the cellulose truck with the hose coming out the back, the generators on the street. I'm up in the attic blowing insulation for the loose fill cellulose. That's my brother Gerard, who worked for the company as well. He's taken off siding on a cold day. That's asbestos siding or cement-based siding, not an easy thing to take off, quite a technical skill. But that was the bread and butter of what we did for the weatherization agency. So our crew was kind of like a New York City based, but we kind of like worked on kind of like suburban buildings in Staten Island. So we did a lot of dense packed cellulose, unlike what people think are the building typology of kind of like New York City. And that's my man, Dense Pack Pete, right? So we called him Dense Pack Pete because that's what he took great pride in. That was actually a day where they were kicking off the BPI program. Steve Thomas came to town. We were showing off all our skills, and that's Dense Pack Pete there. So he took great pride. Pete works in energy efficiency right now. I hope he's watching in the crowd or sees a video of this, but I send him this photo all the time. It's a great aspect of what it's like to work on a team, and people that don't take themselves too seriously, but they take their job pretty serious, that they call themselves Dense Pack Pete. So the humility's out of the way, and this is what the real job is. The real job is on the outside of a building, drilling holes on uninsulated buildings or under-insulated buildings, accessing the empty cavities and filling them with cellulose insulation. Sometimes this process doing a pre-blower door and a post-blower door, we would air seal the building probably between 30 and 50% if we did a really good job of sealing up the building and doing attic air sealing. So it's a great opportunity of what we did. So in 2006, I was had the great opportunity to join the New York City Fire Department. I was assigned to Ladder 80. This is one of our training photos. Where my career kind of like stopped in energy efficiency. I geared up my career in the fire department. And as a fireman, we work 2 24-hour shifts a week, and then we have like 3 days off in between to work in the trades. And I've always wanted to work and keep my training going and build on my career in energy efficiency. So I was really looking to find my way. While I was trying to find my way, I found my way back to where I took all my BPI training. This is the Association for Energy Affordability up in the Bronx. They had a lovely energy training center. And at the training center, we did all sorts of trainings on energy efficiency. And then when ARA hit, and at that time, we started doing workforce development training. So this is a group of students that come from the Sustainable South Bronx, Majora Carter's group. We did a bunch of training for them. That prop there is showing them how to do some air sealing. And we eventually got to do some dense pack cellulose for them, kind of like a workforce development program. This is another one of our workforce development props. My job at the AEA was to be the air sealing installer trainer. So like kind of like the hands-on trainer teaching workforce development and future weatherization employees and current weatherization employees how to do dense pack cellulose well. And as much as I thought I knew, I didn't know, right? So the reality was I wasn't really well trained. I was trained on how to do my job. It was more touch and feel and tradition. It wasn't as science and technique as I learned by working in the props and digging down deep into the process of working there. So we drill the holes, we fill the tube in, and then we dense pack each one of them. You can see that each cavity is 2x4 cavity is fully insulated. So what is cellulose insulation? Dense pack cellulose insulation, and why it's good is, in my opinion, it's above 80% recycled content. It is a very low embodied carbon insulation compared to, say, fiberglass or rock wool or spray foam, some of the other options that are out there. The beauty of the product is that you're using you're blowing it in and it's filling the whole cavity, so it doesn't care what shape or size it is, whereas other bat forms need to be come from the factory in the right size. So proper R value, meaning the cavity is fully filled with insulation, and the R value goes from R3.2 to R4. So one of the things I'll talk about in this presentation is finding the right manufacturer that gives you the right R values to meet those levels. Uniform density throughout is the key component of the nozzle man or the nozzle team's integrity. So making sure that the nozzle goes into the right spot, fills the whole cavity, and that you have some quality assurance or ways to check that you're at 3.5 pounds to 4.5 pounds per cubic foot. And I'll show you ways to check that. There's many ways to do it. And we'll go through that. The picture on the right, you can see that the insulation has been hollowed out of that I-joist 2x12 wall. And that's a passive house level, wall for anywhere throughout the world. It's maybe super insulated wall, but you can see how the insulation is self-supporting of itself. And that means that it won't settle over time and that the whole cavity is filled through pneumatic pressure. So here we have a little video of a tour I took of Igloo. It's a cellulose manufacturer up in Montreal, and I'll play the video. I'll play the sound too. Why not? We'll get crazy. So those are the piles of cellulose. It's recycled paper distributed and put through. It goes through a machine. The piles right there are undistributed paper. That's the gold of good cellulose. It comes down to a certain mix and density. It gets put through the processing machine. That's the bagger. That's the borate, or it could be magnesium. That's the fire retardant and the rotor propellant of the material. There's the bagger. That's the quality assurance machine. It weighs each bag. My buddy Darren from Suprema, and it's a fun experience to see how cellulose is made. So we have how cellulose is made, recycled content. It's a mix of distributed recycled paper and a better quality paper is undistributed paper, but it's all recycled content. It's not new paper. And then it goes through a treating process that grinds it down and softens it up. and then it's added into it is anywhere from like 13 to 15% borate. I personally prefer the all borate. Some of the other aluminum sulfates, magnesium sulfates, I just prefer. I don't like the corrosive nature of those products. Not like borate is inherently, but it's a rodent repellent and a fire retardant. So in the picture here, we have green fiber down at the lower left. We have Suprema down at the bottom that says AB, that's all borate. We have Igloo's product in the green. We also have the new green fiber Sanctuary product on the upper right. And then in the middle, we have the New Will product. I believe it's out of the Midwest. And that's a great product. So those are all different brands that I was able to get to New York City and use on my projects. So now we have, how do you choose how much insulation you really need, right? So if I was using fiberglass, I'd go to the distributor and I'd say I have a 2x6 construction. I've got 1,200 square feet, and they'd sell me how many bundles I need. With cellulose, you got to do a little bit of math, right? So the simplest conversion is down at the bottom here, where you have a 2x4, and you figure out, all right, I got a 2x4 construction, how many square feet, and what's my coverage rate per bag? 36. That's great when you're dealing with 2x4s and 2x6s. In Passive House, we don't deal with 2x4s and 2x6s. We're dealing with odd shaped framing, double studs, Larson trusses, eye joists. So it's not as cut and dry as we may think. That's why cellulose fits really well into the Passive House world, is that it fills the whole cavity no matter the shape and the geometry, and you have to work out a way to get the nozzle in the right spot. So the two tricks to the trade are the advanced coverage chart on the upper left here by National Fiber, and then the residential energy dynamics calculator that I use most often that helps me to figure out how many bags of cellulose do I need and what density am I going for. The general rule of thumb, as you increase in size of the cavity, meaning going from 2x4 up to 2x10, you want to increase the density. And I think the maximum density is really recommended is 4.5. But you really don't want to be below that. So you put it in there, you get your sweet spots, your contingencies, add 10% for just to make sure you have enough material on site. And then these are all the tricks of the tools that I have. So we've got a member of my team, Mike Salufo there. He is putting the tube in the wall, right? So what type of wall is that? That's a wall in a brownstone. So the wall is furred off the wall by 1 inch. The framing is off. So it's about a 4.5 to 5.5 inch cavity, depending on how it was framed, if it was square, if it was level. And our goal in dense pack cellulose is to pack that cavity uniformly so that we get throughout that cavity 3.5 pounds per cubic foot. So general rule of thumb is you drill where it's comfortable, like kind of like right at shoulder height. You drill the hole, you feed the tube up to the top, you pull it back by 12 inches, you set the blower up, and you blow out all the material in the hose. And then as you go along, I'll show you in the video, you go along and then you fill the whole cavity loose fill. And then once you start to slow down the machine, now you're dense packing at the tube, at the tip tube, and then you're slowly being pulled out of the hole by friction and pressure and going across. And then you're going to make sure that you have 100% coverage. So general rule of thumb is if you don't get the tip of the nozzle there to where it is, drill another hole. And that's with there. You can use an infrared camera to make sure that's there, that you're on that you've accessed every single cavity, especially when you're blowing behind, say, the plywood, which is tough to know if you've got the cavities. That's where it takes a little bit of nozzle man and backup integrity to drill the holes for you. And then you also want to keep a bag count as you're going along. So if you know you've done 7 bays, you want to know how many bags you've done through and across. We'll talk about communications later, keeping the team in line of what's happening, what's going across there. So why do we install cellulose as opposed to bats? I feel that bat insulation is kind of like an unfair test. I wasn't really a great student, as you can tell by my college career, but if I'd scored a 95 on a test, I would expect that I did a pretty good job, that I didn't get too many errors. But to then go through and realize that I got a 40 on that test, it's not really fair. So what is it? Is it people? Is it process? Or is it products? And sometimes it's all the above. So if I can do a process that helps me install it better and easier, I might want to go with those products that ensure that the people installing it are set up for success. And that's why I like cellulose, so that when I'm insulating a wall, I'm using the pneumatic pressure of the machine to make sure that it's fully filled and I'm not getting little gaps and errors going across, because I've never met a wall that's perfectly straight or perfectly plumb or level. They always have little tweaks. And when I get material from a factory that's set up, maybe that has some quality assurance issues too. So when you have insulation around electric boxes, they need to be cut perfectly and stuffed in the back. When you have electrical wiring going through the insulation, you want to make sure that that it's split. You cut it and you split it. It's not impossible. It can be done, and we do it from time to time as a contractor. We install rock wool and high density fiberglass bats from time to time, and but the preferred method for us is to do the cellulose, because we find it's a little easier. It takes a lot of time and effort to do it right. So these are pictures of projects that I've worked on. That's that round staircase there is rock wool being put into sound bats. And even though we took our time, it's still not perfect. It still has gaps and compressions. I would say that that's probably around 5% errors. And then the one on the bottom right, where the faced fiberglass R13 is kind of like squished in place and just stuffed, I would say that's closer to 10% to 20% errors. So the effective R value is going down even less. I am proud to see that they did insulate where I think a tub is going, but it's still not perfect. So what type of walls are we dealing with most of the time? So most of my work is done in brownstones on the backsting passive house projects going for passive house. So in the brownstones, our front and back walls here are using a 2x4 stud that is furred off the wall by 1 inch. Then there's a membrane of some sort. It could be an air tightness membrane, like Intello or Sega's membrane, or even Partel's membrane, or it could be plywood. So some of the projects work on, the GC likes the plywood. Some of the projects work on, they like the membrane. So we do whatever the team really wants, and then we fill this cavity with insulation. So this will be a 4.5 inch cavity, fully filled with insulation. The hardest thing to get is the space between the studs. If we weren't using cellulose. You can see a better corner drawing here of the cellulose and the studs and the drywall finish. So this would be from the outside. This would be the inside finish. In this picture, we show how the framing works and how the framing is in place. It's furred off the wall, and here it's done by at least 1 inch. It's a little tight to the wall, to be honest with you there. Maybe didn't get that full area. And this is a way that we're showing that near the door there, we're almost at 5 inches of space behind the door because of framing issues and reasons. So those lovely little markers there are the PHI printable kind of like insulation depth checkers. We've been putting them in place just for the documentation process of Passive House. It lets us know that we took a picture and that we're going to measured the insulation that's there. All right. So we have walls and we have to blow insulation in them. So sometimes on our party walls where we have a fluid applied air barrier and they want insulation for soundproofing or maybe some gaps, but they don't need the air barrier that's there, or the project's not going for certification, but they want some extra soundproofing, we'll put up netting, and the netting will act to keep our insulation at bay. The netting is it's different, but it just acts as like a spring to keep it in. So you can see on the left where it's all blown in. Cellulose is a dirty job sometimes, but once it's in, you can touch every area. You can know the density of it by touch and feel, and then making sure that nozzle goes exactly where it needs to go. The next projects that we work on is going behind plywood. So the plywood on some of our projects, it just gives it that extra resilience of during construction. Once it's up, it's not going to get damaged. If you go through it, you have to take a saw or a sawzall or a hole saw to get through the plywood. Some of the general contractors we work on, with the risk of the front and the back wall, they like the plywood. They like the rigidity of it. Their background is being carpenters, so they like to frame walls and put up the studs. That man on the right there is Louis from AEA. He is nozzle man, kind of like installation blower extraordinaire. He's wonderful at the nozzle. I had a great privilege of working with him for a few years, and they did great work, him and Angelo. This is my team. We're showing the process of that. You have to drill the holes. That's Eva on my team. She's drilling the holes, and then the holes are filled up there, and we got Mike up there that's going across and dense packing that slope, which is probably 8 to 12 inches with the 2.5 inch that's an insulation needle. So these are all done with the smaller tube, and we'll go through the process. All right. So the picture on the far left is how you start out doing cellulose, nice and clean, no dust, with a dust mask on, maybe not, no eye protection on, because I'm never going to spray cellulose on myself. And then in the middle is the process of doing it. So there I'm using an insulation needle, which is a German Xlock needle, and I'm weaving it up into the cavity. That cavity is 5.5 inches, maybe 6 inches. And it's putting the insulation in between the membrane and getting it all the way up to the top there. And I'm using the hard tip of the nozzle to make sure that it's going in the upper corners, and I have a certain amount of feel of when it's coming down. And then the picture on the right is the reality of sometimes you do a dirty job and you get dirty and dusty. There's been some evolution in there that we use better safety protocols and Tyvek suits and different respirators just because of the nuisance of it. These are all wall types, just a little further explanation of them, that they're 2x4s furred through the wall, cellulose is in here, an air tightness membrane that's here, and the 3-4 layers of white brick of insulation there. This is a mock-up of a double stud wall that we haven't had the luxury of actually doing inside New York City on any brownstones, but the wall that we're building it's not really like a double stud wall, but it's not far off. We don't need that same full thickness of the double stud itself because of the attached building on both sides, which are wall types. So nuts and bolts of dense packed cellulose. You want to make sure that your density is at 3.5 to 4 pounds per cubic foot. How do you keep track of that? It's bag count. It's a square footage coverage, but it's also a quality assurance method of like touching and feeling when you have membranes, opening up areas, that taking a piece of plywood off and just checking to make sure that it's done properly. And then you can use a thermal imaging camera to find any gaps or missed areas. Right here, this was blown a few years ago, and they showed that the insulation settled over time. If you have a good crew that has a good machine that's been loved and taken care of and has high pressure, the chances of the cellulose settling are few and far between. But if you're going out and renting a machine from Home Depot and doing it yourself, there's a very good chance that could happen, because the rental machines are just meant for loose blow. They're not meant for high density dense packed cellulose. And I'll show here again is this is a 2x12 eye joist that is filled with insulation, and it's self-supporting. This is the holy grail of knowing if you have dense packed cellulose, is that you open it up, you take out the middle, and if it can support itself, the weight of itself, with 12 inches of it weighing on top of itself, that it can handle the pressure of it, won't settle over time. We do core samples as well, which I'll get into later. So here we have our cellulose machines. This is where the rubber hits the road, right? So we have a few different manufacturers in the US that we're very lucky to work with: Crendel, Cool Machines, Intech, and then there are a few other smaller distributors that I don't know the name. So from right to left, this is Crendel, this one is Cool Machines, this is Intech, another Crendel. This one is a gas-powered machine. And then this is the one that's specially made for RDI, a distributor that kind of like, it's a contractor-friendly machine. Working in the 5 boroughs, access, we bring our machine inside, so we don't pull up in a truck and just blow from the truck because of access and alternate side and things like that. So we need a more mobile machine. So either this machine, the Cool Machine, or the other IDI machine would be beneficial for us if we ever get another cellulose machine. So how do you know if your machine's working well, right? So all the machines either work on generator power. They definitely work on either two 15 amp circuits, or maybe even 3. My machine that I have works on 2 20 amp circuits. If they don't have the right power, they don't operate right. So the electricity is very important. And then each day when we start up the machine, we make sure that from the night before, the last time we used it, that it was clean. There's nothing in the hopper. You'd be surprised at how things can get thrown in the hopper when you're not around on a construction site every day, and even when you are. So we check the inside of the hopper, and then we check the pressure. We check the pressure with the pressure gauge on the right, which checks the pressure at the unit. And then the pressure gauge on the left here checks the pressure of the hose and the unit. So say your machine was making 3 PSI, but you had a bunch of leaky hoses or some bent fittings, you wouldn't be getting 3 PSI at the tip of the nozzle itself. So kind of like the general rule of thumb is that you want at least 3 PSI at the tip or at the machine to ensure that you're dense packing properly. This is my machine in my trailer. It has an integrated pressure gauge that's on there. Lets me know I'm in that sweet spot of the pressure. And here's a quick video of how the machine operates. All right, Cellulose machine's operating. 110 power. Pressure gauge is operating. Agitator is agitating. Shredder is shredding. Machine is pumping. We're blowing in rock wool. Pumping out into the house. All the way up and in. All right. So as you can tell how the machine operates, inside the machine, there's the augers, which chew up the material and process from a compact state. And they start to condition the material. Some of the other machines have a shredder, which even kind of like finely shred the material before it gets into what we call the chamber, the blowing chamber, where the seals are. The seals go around almost kind of like a river boat or so, or just a chamber that goes around, and then the air pressure gets put across. So what makes the chamber work is the pressure from the blowers. The blowers themselves give it the oomph. So if the chamber that the air and the material are in isn't sealed tight, it loses pressure, it's not going to be a good seal. So one of the maintenance keys is to check your seals and change them regularly. The other maintenance key is to make sure that your hose is working with you, not against you. As the material goes through the hose, it's building up friction, and it should break down the material before it gets to the tip. The manufacturers recommend at least 100 feet of hose. Some of them recommend 200 feet of hose. So we're always running anywhere from 100 to 200 feet of hose. And then they recommend that you change your hose every 6 months. We don't work every day blowing cellulose, so normally ours is around like every year or two on our frequency. I keep hours going across. Tubes. All right, so dense pack tubes. Sometimes you have winter dense pack tubes that the plastic is harder, and maybe the plastic is a little softer under colder conditions, and it gives the ability to bend. Then you have summer tubes that are kind of like more rigid, and under warmer conditions will be stronger and not bend as much. The tube thickness is 1.25 inches and 1.5 inches. My preferred tube is this Tiger Flex hose here. That gives me a decent amount of production that goes through the hose. I am considering getting the 2-inch Tiger Flex hose. Every time you increase the diameter of your hose, you increase your efficiency or your production quite a bit. So from 1.25 inches to 1.5 inches, and then we've discovered these nozzles, these Xlock hardened insulation needles, and they're just a rigid tube that's bent, and it helps us get into those deeper cavities. There's a few more videos that'll show you what's going on there. Now, this is a longer video. Let's see the dense pack process behind the wall. All right, so we have the different wall types working on. You guys saw this already. Drilled. I filled up to the top already. Now I'm going to fill down. I'll stuff the tube all the way down to the bottom. I know at this mark that I'm down 4.5 feet. I'll pull up around 6 inches. I'll start the machine and it'll start packing it up. The whole bay is packed loose fill. And now we're going to densely pack it to 3.5 to 4 pounds per cubic foot. So you can see I'm wearing a PAPR and a Tyvek suit there. You get a little tired of getting dusty and blowouts in your face. You'll see the blowout soon. You wear the PAPR just to keep the dust out of your face and your eyes. It makes working a little more easier. Take it all the way down to the bottom again. All the way down to the bottom. And just for that extra pack with air pushed over the. So as it goes in fast forward mode, that extra pack, the tube blowing air only, pushes all the cellulose to the side and separates it through pneumatic pressure and gets it all the way down to the bottom. So you're getting a mechanical pack of that and then getting a pneumatic pack on your way up. So especially behind plywood. This will follow the machine all the way back. We're up almost 3 stories on here. They're replacing the stairs, which makes access always a lot of fun. Bring you back almost 150 feet of hose there. And this is our machine set up on site inside, working on 2 different power sources. A little quick image of how the agitator operates. This is dense packed cellulose, fully filled cavities, making sure that everything is 100% filled. And that's one of our core samples that measures how much density there is. All right. One of the infrared pictures. I'm going to speed up now. Hopefully you get through all this. I know I'm a little backed up on time, but this is a way that we keep track of which cavities are being next, that we don't skip, especially when you go to lunch or you take a break. The friction in the machine builds up heat, and when you install the insulation in it, it goes in slightly warmer. And the infrared camera is just a great way to make sure that you didn't miss any bays or nooks or crannies or odd framing members. One of the lovely hazards of cellulose is static electricity. One of the tricks of the trade is to throw a little graphite inside the machine to make it smoother. But on a low humidity day, the static electricity, sometimes it gets you no matter what. And it always gets you when you're least expecting it. Wow, that hurt. And it's it catches you off guard. This is one of the benefits of doing cellulose is that in a passive house project, it helps you find some of your leakage.
Leaks and holes.
The hole there.
Blowing out.
So we've got all the benefits of cellulose. Now, how do you keep track of density? So this chart was put together by somebody that I consider a mentor and a friend in the industry, Bill Holstrick. He used to work for National Fiber. The man was a jack of all trades when it came to cellulose. He knew everything from the machines to the product to the process, and really supported the guys in the field that were doing the work. I was at the national weatherization, kind of like regional weatherization competition, where it's kind of like a rodeo, and he helped one of the teams win the competition. He tuned their machine, he checked their pressure, and I had a little bit of envy that we didn't participate in it, but they had a really good coach. So Bill was a great coach, and then knowing where the world was going and deeper cavities and higher densities, he created this chart, and I've been using it ever since, and it's been a staple of my practice. So one of the things that we do on every project is we do core samples. I choose an area that I know is hard to work. Either low, high, up on a ladder, that maybe I'll take a mark on the wall, or when we know we took lunch, and we'll open up that area and we'll check the density. So we open it up, we measure it, we weigh it, then we measure the 5-inch cavity, 69 grams. That comes out to 4.2 pounds per cubic foot. So I'm confident that right here at the hardest level that we have hit our density. This is our density check station. We use lunch bags, right? So rather than putting them in and hand stuffing them, we just take paper bags, put them in, paper's paper, and stuff them back into the cavity. And there's no vapor density change whatsoever. We blew up the chart, we added a logo, but I do give Bill credit for creating the chart. But it's a part of our practice and our process. This is mainly here to make sure that nobody else, that nobody throws it out on us, really. So here's a quick little exercise of the technique and the technology of Passive House is that we have a 6-inch cavity weighing 102 grams. We would go to the 6-inch here, follow it all the way down, and we'd see what our gram weight is here on the scale. And we'd know that at 6 inches, we're greater than 5 pounds per cubic foot. So this is just showing you guys how you would use that chart. Not rocket science, but sometimes you just need a little bit of hand holding.
All right, we're
House product.
Another video.
Clinton Street. We're doing dense pack cellulose here in the walls and the ceilings. We'll go downstairs and take a look at the machine. Pretty typical of our projects. Got Mike loading the cellulose machine. Nice, cool machine. It's the 1500. We're blowing in Suprema cellulose from Canada. Very nice product, clean cellulose. Comes all the way through. All borate is the AB. I think that's the important part of the product differentiator. Timmy's drilling holes there, opening up so that when we move to the next floor, it's open. He's on the second floor. We're up on the third floor. That's our insulation needle. Our density check station. We got our scale and our 4-inch dryer vent pipe. Kelly's blowing in with the ventilated rotary nozzle. Our goal is 3.5 pounds per cubic feet up in the ceiling. Kelly's got it up there. The ventilated rotary nozzle is a German Xlock nozzle. It helps to blow in at the end, puts the tube fill. It's a nice process. All right. This is the Xlock nozzle. So in my training, I went over to Ireland and met a good friend that hopefully I'm able to get on the show. His name is Roman, and he's a German guy working in Ireland doing dense pack cellulose and passive house work. And we just instantly at the training had like a bond. Like, oh, what kind of machine do you use? Like, oh, what's this? And we shared knowledge and back and forth just by traveling outside of our borders, realizing that there's other cellulose machines and manufacturers out there, discovering that the Xlock brand is out there, innovating and really kicking the cellulose world to the next level of those thicker wall assemblies and everything. So this is the S-Jet. The S-Jet is kind of like the tube fill method with the rotary nozzle on it. The tube goes in and down, just like we would take the dense pack nozzle, but it's doing it at a larger size hose. And then as you come up to the top, you do the ventilated size. It's dust free. It's a nice. We have it and we use it quite regularly. But it's a great innovation and project. So this is the ventilated rotary nozzle in practice. It to be honest with you, it works a little better in solid cavities. So if you have 2x10s or 2x12s and you're blowing small little cavities like Mike is here, it's really good at doing that. Whereas we're a little bit more used to getting the flexible tube and getting a little more tactical feel inside the cavities with the smaller dense pack tubes when we have open cavities, say trusses or double stud or furred off the wall studs. We have the ventilated rotary nozzle. Show them the flange. Pull it out. Got the little lock. Locks in. Got a bag. The bag acts as the air lock for the nozzle. Goes in. It's got a curve to it. Spin it around, Tim. Show them how it spins. All right. So he's got the nozzle in the bay. These are solid plywood box golf, kind of like cathedral ceilings. Each one is about 2 or 3 feet. See the bag's inflated. The nozzle's pointing this way. So it's fully filled. They're done. We'll just take a handful and plug that hole. This is the Xlock Insulation needle. You can see how it's got a curve to it. And Timmy's going to poke it in the wall to show how you get a fat cavity filled with insulation. He takes the tube and he's angling it. That's why the tube has an angle. It gives you the down at the bottom there. Now go to the other side. Beautiful. This is the Xlock Insulation. And this one's just doing a different cavity. It's going up. Just shows that the tube is going up and to the right at the top. He can feel it. You can touch it. You know where it is. And it's just a pretty good way of doing a larger cavity quicker and faster, because cellulose is all about production. I'm doing 2.5-inch opening and getting that hard nozzle into the spot. It helps me to be more productive than working with the 1.25-inch nozzle that would be. So one of the other tricks of the trade of doing cellulose are these density boxes. These are 2x4 density boxes. This is more for home performance or residential work, whereas you'll be setting your machine up to know what your settings are, your air pressure and your gate to do 2x4 walls. And how it works is that this 2x4 box is 2 cubic feet of volume on the inside, 3.5 inches. And when you blow it at dense pack, 3.5 pounds per cubic foot, it should increase by 7 pounds. So you should take that density box, weigh it with a fish scale or a bathroom scale, and then you would know that it's at the right density. It helps you set your machine up. One of the things we'll be doing in the future is creating density box checks that represent our walls, either with Intello or say plywood. And then the trick of the trade is once you blow that density box is that you think you did a good job before you weigh it, you take off the cover and you hold it above your head. And if you didn't do such a good job, you get a cellulose shower. And then if you did a great job, you did it. That's the kind of like tradies a rite of passage, I guess you could say. In our projects, we also do not only walls, but roofs. This is a 17-inch cavity. When we do the 17-inch cavities, most of that's an I-joist, that one. You really have to spend a decent amount of time making sure that you get the nozzle in the right spot and doing those density checks. That's where those insulation needles really come in handy. We've done other cavities that are up to 24 inches. This is a garage ceiling in a passive house project in Harlem, multifamily project. We did 24 inches of dense packed cellulose in this area. We got almost an entire tractor trailer filled with cellulose, and the logistics of it. Luckily, it was in an overpass and a garage because we were able to store the cellulose in the garage area. And it was fun. And we used some of the membrane to keep the dust down and help us from picking up, from having to clean up. One of our other tricks is to put up membrane as opposed to drilling holes in the plywood. That gets tedious and laborsome. We throw up a membrane or a netting, and then we'll blow through that, and then we'll peel that down and put back up the plywood that goes in there and tape the seams. So this is a trench method is what we call it, whereas we go left, we'll go right. And we can do almost an entire ceiling with 2 trenches and a few holes rather than having to drill a hole every single one and then patch them. So it's one of those things. The key to getting cellulose machines to work is regular maintenance, just like an airplane. Hours, how many hours has the machine been running, and then change, put your lube in the gear oil in the right spots, and change your seals. The one in the middle is a split seal. When you run your cellulose machine and you see volcanoing and things that are that are popping out, means that you have air leaks and you should change your seals regularly. The thing I like about the Cool machine is that it's rather easy to work on. We're able to take out these augers, disconnect the chain rather easy, change the seals without having to do acrobatics and getting under a 200-pound machine, and it's nice to work on. This is our setup, our hoses that get changed regularly going across. This is our machine inside. We have a cover, making sure that the team that we're working with isn't throwing, like putting a screwdriver on and it winds up in our machine. That don't ask me to know how that happens. This is our setup when we had the luxury of being able to park for a few hours in front of the fire hydrant and listening very closely to make sure that you're not blocking for a fire. But this was our setup there. Logistics. So having a good partner that could deliver for you is important. Deliver in pallets, quick, fast, efficient, and then having a good crew of guys ready to offload and get it in the building without too much distress and despair. So we use IDI here in New York from Long Island. We have purchased half trailers and full trailers worth of cellulose. It just tends to be a little troublesome on the logistics and the warehousing, and renting a forklift to load the trailer or the truck itself. The other way to keep track of how much progress you have is keeping track of how many square footage you covered and how many bags you've done. The hashtags, hash marks on the side here is our daily production. This is our daily pressure test for PSI. We got 108 delivered. We had 10 from the garage. This is who was working. And it's kind of like a challenge to see if we can beat the other day's production. Safety. So Pull rate is not technically on the list of a respiratory hazard, but it is kind of like a nuisance in that if you blow it every day, it can dry out some of your skin and make it irritated or so. So over the past few years, I've as the owner of the company, I've just kind of like implemented good safety protocols, which means Tyvek suits to keep the dust off your clothes so you go home and you're not covered in it. And then the respirators, making sure you're either using a full face piece respirator to protect your eyes or the PAPR just to make it a little easy to work on. And that goes for not only blowing cellulose, but also installing rock wool. Everyone's got their Tyvek suits on, they got their gloves, their respirators are on. You're working above your head, you're looking up. It's very easy to get things in your eyes. And you get something in your eye, you're shut down for 5 minutes. It's a production hazard more than anything else. Other parts of safety are this negative air machine. Creating dust, you want to control the dust and bring in fresh air to keep that across. So this is a HEPA filter, collect the dust, just take a negative pressure, keep the dust from being in one zone to the other. And lighting. To me, on construction sites, lighting is the biggest hazard because even though it's under construction, they put up temporary lighting. It's never perfect where you need it. So we always have temporary lighting. And the last part is communication, right? A funny picture of the guys that are able to work with me, but we have these walkie-talkies and we talk like we're at the firehouse. Nozzle to control. You got 15 bags left. All right. I think I have a clog. He checks the machine. We shut it down. We purge the machine. It prevents us from having to break down the hose and chase leaks. And communication is important, especially when you're working with a limited man crew. Somebody falls off a ladder, twists their leg, you want to stop right away, be able to help them. So we work with radios and voice mics and things like that. It's important. And then the last part of the presentation is kind of like the lessons learned of quality assurance. While walking around with the thermal imaging camera, checking for and we missed any bays or cavities or so, we noticed this cold spot in our insulation in the ceiling. And we were like, what's going on there? And what we didn't realize was that the permanent roof wasn't on. So the roof wasn't a permanent roof. It was just a temporary roof on the top, and they developed a water leak, and the water leak was showing through the cellulose. So then we had to take out all the cellulose that was up there, and we needed to do it. But the thermal imaging camera kind of like helped us find it. And then it wasn't such a big deal because the drywall wasn't up. It was just a few bags, a patch, a pole, and a replacement. Just took out everything that was wet. Once they put the final roof on, then we went back and we redid the work. So kind of like the lesson there is to don't blow cellulose in a brownstone roof unless it has the permanent roof on, or the temporary roof that's the underlayment, or something that's a little more durable than what's currently up there. So I just want to thank you all for that presentation. I think I've used all the time I possibly had. Boom.
Wow, boom indeed. How about a round of applause right before we hand it off to Zach?
Yay, Kevin.
Amazing. Kevin, that's incredible. Thank you. I'm going to do just some quick announcements here, and then we'll get into Q&A. I know there's lots of questions. First of all, I want to thank our sponsors. Our sponsors make everything possible for us at the Passive House Accelerator. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Bax Ingwe Architects, Glavel Foam Glass Gravel, Minitair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwool North America, Stocorp, and Zola Windows. Thank you also to our champion sponsors, Icon Windows and Doors, Proseco, and SIGA. And a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan Insulation and Air Tightness, Brooklyn Solar Works, Euroline Windows, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So a big thank you to our sponsors. And on the Passive House podcast right now, the current episode, you can check out my interview with Kevin. Please do. It's a really interesting conversation and dive into Kevin's history and the work that he does. So I think you'll really enjoy it. We also just released the latest issue of the Passive House Accelerator magazine, and this is one that's focused on climate action from North America to South America. So you can find that at on the Passive House Accelerator website, both in electronic form as well as PDF copy. Tomorrow on the Passive House Showcase, the first showcase of 2022, we are joined by Bomi Jung of Topsite Advisors and Yuan Tan of Rocky Mountain Institute, and they will be presenting Decarbonized Homes, Healthier Communities. So insights from the recent RMI report on beneficial electrification and affordable housing and climate justice, and the role that Passive House plays in all of that. So please join us tomorrow for the showcase. And then next week on Construction Tech, we are joined by Abby Muser-Herr from Precipitate Architecture and Planning, and Katie Jones, the homeowner of this house, this Passive House straw bale project. They'll be diving into the carbon implications, the calculations, and all sorts of interesting permutations in this project. And I think that's it for me. So on to questions.
Wow, amazing stuff. We are going to now switch into the overtime. And I have to say, we actually start off the year going T4. You know, typically it's T3, but T4 because, Kevin, you went top shelf with the technical, the technique, and the technology. Bravo, my friend. Amazing information. And I got the pleasure of hanging out with Kevin a few weeks ago in New York, and his crew. There's such a good vibe that Kevin and his crew bring to the job site. And as you can tell, if you're in New York and looking for a new career, hey, hang out. And it's unofficial, but I am the franchise writer for B&B Insulation. Text me, connect with me. We can start moving Kevin's knowledge across North America. Because as you saw in the last 45 minutes, maybe 50, whatever, we all enjoyed it. That was amazing detail. Everything you said, Kevin, your experience, you gave it to us. So thank you for sharing. Because again, collaboration over competition. Shannon, let's get into the questions. I know Mark wants to chat, but there's just so many questions. We had such a great turnout because, Kevin, we knew you'd bring it. You brought it. And 2022 is off to a great start. So let's dive into the questions.
Absolutely, Sean. I just am about to bomb the chat with the tips and tricks. Kevin, I was trying to keep track. I know I missed some of them, but they're in there and they're really great. I am so grateful that you've shown me what to look for on the job site. It was like the next best thing to being there. Really appreciate the in the field footage and those tips and tricks. So without further ado, our first question is from Barbara in Oz tonight. Hi, Barbara. You want to unmute and ask your question?
Yep, going ahead. Thanks, Kevin. That was really, really good. I'm wondering, can cellulose be made from shredded books? I have a very large professional library. I can't sell it because and I can't even give it away because libraries have too many books. They have no storage space. So I'm thinking, well, I'm planning a passive house. Maybe I can shred my library. What do you say?
So I think the paper stock is different than what newspaper really uses. I think it's a little than what normal cellulose producers really use, especially on a small scale like that. Early in my career, I had a bunch of ideas that I thought I could get past the goalie. And I was a high school wrestling coach for early on. And I did a newspaper drive at the high school to collect newspapers and tried to trade newspapers with our next cellulose delivery. And we got like 2 tons of newspapers and it was great. But I don't know if it was really worth it because 2 tons of newspaper was a lot of logistics to get. And then to get it to where the truck was meeting us, it was fun, but it's community based. And, you had to get people involved, a little bit of awareness for the high school kids, which was great. I know that there are certain cellulose manufacturers that are kind of like more changing their process towards more cardboard based products. I know that's been a challenge because from an installer level, one clog will shut you down for like 45 minutes or so. So that cardboard really needs to be processed pretty finely to make sure that it's not going to clog on you. But paper's paper, cellulose is cellulose. So, I mean, the innovation I think is available out there between where it is. The irony of cellulose is that it's really it's a family run local business. No matter, there's a few like really big companies and conglomerates, but for the most part, they're like small manufacturing plants that are like, hey, we can make a difference. So they're regionally departed. The Cellulose Insulation Manufacturers Association has some good information on like how you set up a cellulose manufacturing plant. I'm happy to share the video or the pictures from the how it's made cellulose until they yell at me. It's a cool process. I know when I went to the facility, I was blown away at the technology that was there.
Yeah, the thing of it is, a lot of my books are art books, so the paper has, I'm not sure what's in art paper, chalk or something, so they take color photos and you get a really smooth surface. So it's not newsprint type paper, it's mostly heavier weight, so it's got additives already.
Yeah.
I don't know if that little pun was lost on everybody else, but when Kevin said he was blown away, it wasn't lost on me.
No, that's good. The other thing I wondered was distributed versus undistributed. And then Sean Maxwell said distributed means post-consumer and undistributed means pre-consumer recycled content. And that means like unsold newspapers or what?
Yeah, so the best, highest quality cellulose is undistributed. No like flyers thrown into the mix. Just they thought they were going to sell more newspapers than they did, and they had the surplus. So the best cellulose that I've used in my years, most consistent was National Fiber, and they used New York Times unsold newspapers at certain percentage, and it was just done really well. Everyone has their special ingredients to their products. There is difference of every product, but you can tell, like as an installer, you know which ones are giving you a headache. If you get a bunch of clogs and things caught up in your augers, like you shouldn't really be able to read the print on the paper. Like when I started my career in weatherization, we would do the cellulose lottery for lunch. We'd take the pick three. Somebody would find 3 numbers randomly in the cellulose, put it on there, and we'd play the pick 3 at lunch. And we won like 5 times. It was fun, but from like buying the product now, you shouldn't be able to do that.
Right. Okay. Oh, well, the New York Times, all the news that's fit to print. Obviously, the ink doesn't matter in the cellulose, so that's good. Thanks a lot.
Thanks, Barbara.
Thank you, Barbara. Our next question is from Susan, or excuse me, I'm sorry, from Cameron. Cameron, are you still with us? It looks like you are, but you're muted. You want to unmute and ask your question? If not, I can ask it for you.
Yeah, the question, the question that I had was the availability of doing something for the chemically sensitive using papers that are reasonably free of toxins like the inks and such like that.
I'm not familiar with the toxins that are in the inks. And I think there's a certain
the oils and so forth. Back in the 80s when I was doing some healthy housing, oddly enough, I think it was in Kansas, that they had not quite craft paper that was unprinted, that had to be used in the pig housing. You couldn't use anything else because it would cause problems with the growth of the pigs. And so that's what I used in Texas, but it's real difficult to get a hold of. And I didn't know if there's any, if that had grown at all, but apparently it's not. The more fun question I got to ask, this is a real quick one. All those holes you're putting in plywood, the holes, what sort of hole saw bit are you using for that? You gotta have to have a favorite.
The Relton carbide tip, kind of like it's got a spring on it. It's expensive, but it's a lot better than buying, 10 Milwaukee.
Yeah.
and getting them out too. So the Relton is the bee's knees.
Thank you very much. Good presentation.
Thank you.
I'm glad you asked that question, Cameron. I was going to prompt you because I saw it in the chat. Who do we have next? How about Susan?
Hey,
Hey,
thanks.
Susan.
Hey, I had a couple of questions, but one of them actually towards the end was just all the holes that are being cut, not so much about the drill bit. Thank you, Kevin, by the way. That's awesome. If there's holes that you're making, that's in the vapor barrier. How often does it happen that, the air tightness barrier, how often does it happen that there's like problems with when you do the blower door test, or is there?
So every hole that gets punctured in the air barrier, we patch with tape. So every hole gets patched. So our latest trick is to just buy a 6-inch roll of Vata or whatever tape we're using, and then just clean it, wipe it, and then tape it properly and press it. So there are times where we'll miss a hole. It's teamwork, and then most likely we're doing the blower door anyway, so we'll find them. But
All right.
we always leave a roll of tape with the GC, and we buy beers for people who find our mistakes too.
Oh, dear. Awesome. And then I had actually one last question was also related to the material, the product. And I was just wondering, is there really that much newsprint still these days in the world? And someone mentioned that there's lots of, junk mail. I don't get it anymore, but just curious, like, isn't it a dying product?
It's forecasted to be dying, but currently it's still in circulation, and there's still a decent amount of recycling happening. And like I haven't, none of my distributors have said they had a hard time getting raw materials or product, but I was in a very good position during the pandemic and the slowdown, because there was serious distribution things with other manufacturers of other kind of fiber-based products. So we had plenty of cellulose, but we didn't have enough of the other stuff.
Cool. Thanks so much. It was awesome. Thanks, Kevin.
Here in Ontario, it's already slowing down though. They're already having trouble getting raw material.
Yeah, that's where I'm coming from.
It's a logistics thing. So you don't want to take your raw materials halfway around the country that are being recycled, and you don't want to take, after you make it halfway around the country, you want to make it as close to the source as you can. Not like Montreal is any close to New York City. I've always been like, why don't we have one in between all 3 major New York City newspapers? Like, oh, you guys didn't sell enough newspapers, just drop them off down the block. Thanks. But if I won the lottery, maybe, and wanted to deal with a lot of headaches of being an industrial entrepreneur, but
Now, Kevin, just to follow up on that, because there's a little bit of chatter in the chat, can you use the machines that are built for paper and blown in cellulose for things like blue jeans or other packs?
what was the question?
Can you use the machines that are built for paper to do blue jeans or other blown in materials?
So blue jeans does not currently come in a loose bat form or a loose blown in form. We have blown wood fiber. We blew the 475's office with the Gutex wood fiber. Just tends to not be cost effective to ship air across the pond or so. And then we do a decent amount of blown in rock wool. So Thermofiber has a product, Insulfill, that is pretty good. Higher R value.
And same machines, right?
Same machine. No real gearing up difference. The wood fiber, the rock wool, we've done it where we blow it in. We blow it on wet with glue. With steel stud construction. We think that's a potential area of growth for the market, of doing perfectly insulated rock wool walls with glue and blowing it in, then scrubbing it down. But we'll see.
Excellent. Well, thanks for that question, Susan. And next up is John. John Burrow, would you like to unmute and ask your question? John, are you still with us? Yes, you are. Maybe you want me to ask it for you if you can't unmute. See where we've got your question here. So John's asking about the R4 US value, the lambda value, and Do you need to quote thickness?
So I'm not sure of the lambda value and how that really converts from metric to IP, but our general cellulose dense pack goes from our 3.2 IP, BTU per square foot per hour or whatever, all the way up to 4 based on the manufacturer. So there are new ASTM tests that some of the manufacturers are using that get you the higher 3.84 pounds per cubic foot. The old adage was that more air equal to higher R value. So loose fill cellulose has a higher R value of 3.6. Dense pack cellulose has less air, so it would be 3.2. But I guess based on some of the testing processes, they've been able to market and to give supporting documents that it's 3.8 for, I guess, to keep up with the competition of high density fiberglass that's out there. But I know that when we do a dense pack, that it's fully filled and it's getting the highest available R value that we could put in the wall.
Excellent, thank you. Our next question is from Hans. Hi, Hans, you want to unmute?
Hey. Yeah. So first question was about how do you ensure that the cellulose that you get is the quality that you need?
Never order a truck worth of cellulose unless you've had a sample or been able to use it before. Like I won't order unless I've gotten a pallet from them before, or I've seen their product or so. So once you get a pallet, and then like one of the reasons I went to Igloo is to see their process, their quality control process. Like they weigh every bag. If a bag comes off the line and it's not at the right weight within 2%, it gets kicked off the line. They do burn tests at every day. They're doing their, they have a decent quality control process. It's not it's not that far off. Is there ASTM or specs or standards that are helping us? I don't think so. In weatherization, we wrote a specification that just helped signify what high quality cellulose was. And most of that dealt with making sure that there wasn't a bait and switch on the borate and aluminum sulfate. That's really where most of the cost of the product is that the 13% borate got from wherever in the world tends to be a little more expensive than the magnesium sulfate or the aluminum sulfate. And then those products, those fire retardants and rodent repellents, they kind of react a little bit with water. So if they do get wet, they have like a corrosive nature to them. They smell a little weird sometimes when they get wet. So the better product, in my opinion, is the borate, the boric acid.
Okay, cool.
And then the shredding, I think you mentioned, like that's up to the manufacturer really, what their mix is. Like sometimes you'll get a sloppy mix where it'll have a bunch of like plastic bags in it, or a bunch of like too many wax-based flyers and stuff like that. But as long as you're not getting clogs, I don't really see it being a huge issue for me. Once you start getting clogs or you question the quality, you get what you pay for sometimes. So
yeah.
Kevin, that's a good segue when you mentioned the clogs. Somebody asked what volcanoing is. Can you expand on that?
What is?
Volcanoing.
Oh, so inside the machine, when you have a broken seal, when it goes through the chamber, air escapes and it pushes up this like splash of dust. So volcanoing is this like kind of like eruption inside the machine of a poof of dust that says that your seals are you got a broken seal and that you need to do maintenance. You could also check that on the gauge too, the pressure gauge, that every time it goes through one of the chambers, you would see the pressure drop.
Thanks, Kevin. It looks like a few folks who asked questions aren't showing up in the queue. So I'm going to keep moving along, but if I missed your question, just shoot me a message and let me know you're still here if I missed you. So Michael has some questions for you, Kevin.
All right, let's go.
Michael, you want to unmute and ask your question? Did we lose him? All right, how about Buck Moorhead?
Kevin,
Buck.
hi, how we doing?
What's up,
How
Buck?
are ya?
Kevin, hey, great presentation. I can tell you I'm not surprised.
Thank you.
Pleasure. Listen, I had a question about the level of flame retardancy, that fire retardant additive in the manufacturing. Like, how far does that get? Like, what happens when cellulose actually burns, or does it burn, or is it just, is it get to incombustibility, smolder, smoke?
So I'll give you an anecdotal information, like my experience as a fireman with cellulose. When I go to a fire in a cockloft, in a roof in a New York City building or so, and we see cellulose, we are happy to see the cellulose, because if the cellulose has been put in loose fill or dense pack or somewhere in between, we know that there's not a lot of, the cellulose is just going to smolder. Whereas if that same space is filled with fiberglass, the amount of air that can move through the fiberglass is going to take the fire and move it across the cockloft. The other marketing piece that some of the cellulose manufacturers do is they'll take a blowtorch and they'll melt a penny on a pile of cellulose. And then what'll happen is that the penny will melt and the cellulose will smolder. It won't ever really actively burn. So dense pack cellulose doesn't, it goes to the smolder phase because it's done dense and that the outer layer just chars. It's not that it's non-combustible, it just, it doesn't actively burn. And when it's filled in the entire cavity, it's not like there's this free flowing of air for it to burn.
It's like a fire stop. It's like a continuous fire stop in those partitions.
So
right?
New Wool has had their product certified for 2 and 3 hour firewalls if you go on their website. So rather than doing like 2 layers of sheetrock or 4 layers of sheetrock on both sides, they have something that they've had tested. I don't know all the technical natures of it, but if you're doing demising walls between apartments, they've had some good advancements of using cellulose dense pack in those demising walls to save you money on some of that nature.
Interesting. With like a metal stud, one would assume.
Yeah, it would be like a furred off metal stud, staggered studs between 2 apartments, and then blow in cellulose, or it could be, I think it might be garden style too, apartments where it's wood framed, but the cellulose acts as it helps the rating or so.
Yeah, excellent. Thank you so much. Appreciate it.
Thank you.
Thanks, Kevin. I know Reed had to take off early, but he asked a good question in the chat, and they're coming in so fast, I can barely keep up, which is awesome. So Reed asked, is there a list of questions I should ask my installer to qualify them?
Yes, just like anyone getting on an old airline, you walk onto it, it's a 1945 single engine Cessna. Can I see your maintenance records? When was the last time you checked your pressure? Those are very good questions to ask your installer. Do they know what the pressure is? What's your quality assurance process? How do you know you're achieving the right density? What training have you taken? Have you taken any, what certifies you to be a cellulose installer? Is it just a man with a van and a rented machine? Or is it like, I know what I'm doing and this is how I do it and this is where it is? Just, that's kind of the process, asking them like just some good solid questions, like how do you make sure you put in the right amount of cellulose? No, we just feel it, this, do you measure, do you touch it? So passive house is great in that you're most of the time with membranes, it's very tactical and that you can touch and feel, and it should feel like a firm mattress. And then with a little bit of science, so taking out the core sample and measuring and weighing, then you're a little bit closer to that. But it's still at the end, it's the nozzle man's integrity to make sure that he got every single bay. Like at the end of the day, we sign the wall, we put our initials. This way I know I did from the first floor to the second floor to this bay. And then when somebody else takes over, it's like, oh, Mike did that one. All right. And Mike's got to learn how to, you can't be coming in on holidays, so. But.
Great, perfect. Our next question is from Elise. Elise, I'm sorry. Hang on, Elise. I forgot. I've got Michael next. Michael came back. Come on up, Michael.
Hey, how are you? Hey, Kevin. That was fantastic. as I expected it to be. Actually, it's even better than I expected it to be. No offense. So, question for you: sequencing. Only because I know it's one of the things you've made such a huge difference on in our projects. Sequencing, when is it good to have you meet the contractor first? What do you want to tell them in the team? What do you recommend? And not just when you start, but how they start to work with you.
So the preferred thing is to almost have like a Passive House 101 with the team. So if it's the general contractor and their team, just give them like an overview of what Passive House is. That really sets the tone, and maybe like a mock-up, or show them, bring something tactical that they can touch or see what cellulose is, because sometimes they've never dealt with it before. And then as a team, deciding which air barrier we're going to use. Is it membrane or is it plywood? And then coordinating the logistics of, all right, you tell me how many times am I coming and going? Like, because every time I bring in my machine and bring in cellulose, there's cost and logistics and mobilization. So the closer to one-stop shop, like I'm in and I'm out and I got 12 pallets of cellulose and I'm done, the better it is, as opposed to staging where I come in, do the first 3 floors and then come back out and then do the next 3 floors and then the roof, so that to me, that's the better solution. I know reality and schedules, things happen. It's just, it's a matter of just communicating what needs to happen when.
Thanks, Kevin.
Thanks, Kevin. Thanks, Michael. Elise, sorry to make you wait. Why don't you unmute and ask your question?
Of course. Hey, Kevin, how are you? That was super interesting. Thanks for that. We have a client looking to blow in, what is it? It's just escaped me. Oh, Xlock wool. I was wondering what your thoughts were on Xlock wool in comparison to cellulose.
Kevin,
Xlock wool would not work through any of my machinery. So they have a different process of installing. They install through a insulation vacuum, and they hand shred it and then they feed it into the vacuum. So it's a different process than I'm used to. And then, cost comparison of labor and material, the Xlock wool is a luxury item, luxury, or I wouldn't say, the price for it's almost at that luxury level. But it's really kind of like, it's at that the upper price point of what could be,
Cool.
Hey, Kevin, maybe I can just jump in there. Just one of our colleagues at First and 5, Oliver, just did his extension on his house, and he did 12 inches of cellulose in the main wall, and then the service cavity they used Xlock wool, and they got shipped a brand new installation machine to do it.
Oh, wow.
So look out for that video with Xlock wool in the next couple months. And I mean, again, our colleague was like, it is a luxury item, but they made it work through netting. And actually in the end, for the service cavity, the price of the Xlock wool was on par with cellulose because of the material and so forth. So just connect with Xlock wool in the next month or so. I know they got the video this weekend and they'll have it. So it's because that was the main issue for a lot of us. It was like, hey, great product. How do we get in our walls? They've made some great improvements in the last 2 months. So look out for that.
Yeah. Because the big thing from buying from any of the manufacturers, either rock wool, cellulose, any of them, it's sales, service, and support. So meaning you're not just selling me a product. It's as an installer that is operating machinery. How do you help me operate the machinery well? And then how do you help me to ensure that I'm installing it properly? Are you supporting me? Are you training me? Are you giving me the opportunity there? And the gap in the market is the machinery, like getting technical people out in the field to help us knuckleheads realize, like, oh, you need to do this. You need to get a better machine. You need to change this. The innovation that's out there as a group, I think, could be a little better. So
perfect. Thank you so much. That's super helpful.
Thank you.
Great, thank you, Elise. How about David Newman? Are you here with us, David?
Yes, hi. Thanks for the presentation. I got a couple of questions. First of all, I noticed that when you're using an air barrier and you're filling there, that there was basically 2x4s on top of that again. I'm assuming so you can have a flat surface to install your finish on. Is that correct?
The 2x4s cut in half, the 2x2s, they're used as a service cavity and furring strips. So when we use the plywood, not so much to like hold it at bay, but just to give us the access in the service cavity to run communication cables, electric cables, plumbing, whatever it might be there. When we're using the membrane and the membrane is going to stretch, then those counterbatting or the service cavity is held in there to keep the cellulose from bowing out the wall and coming in like in passing on the drywall. So it holds it at bay.
Right. So, okay. So then could you do a 1x material? Is that thick enough? Like a 1x3 or something? Because I mean, wood's so expensive now. I look at that and go, oh my goodness, like that's $10 a 2x4. I mean, it adds a lot of price, right?
Yeah. So my preferred method is to use plywood right now, is to run it in strips through a table saw, and then to do a strip vertical and then a strip horizontal, give me 1.5 inches. So a strip of 3/4 inch plywood, horizontal on the studs, and then vertical on the studs, and then horizontal across to give me like a cleaner, more like basket weave of the service cavity. That tends to be a little better for me personally to coordinate with the team.
Then when you're plugging the holes on the plywood install, what do you use to do that?
So normally we use the hole with the hole saw and strips of plywood backer. So it'd be 2 screws on the backer behind it, catch the strip of plywood behind it, and then 1 screw in the middle of it to catch the plug, and then we'll tape over it with whatever air barrier tape we're using.
Okay, cool. One last question then. For like a flat roof, like in a house, I have a flat roof situation. I'm still concerned about settling over time, and I'm just wondering if that's just like not very well founded. Like say I have a 12-inch cavity on a flat roof and I want to then fill it. Are you really confident that if it's done right, that it won't settle significantly or sufficiently to create a problem?
Yeah, so 12-inch cavities, I've done 24-inch cavities where they've been dense packed and checked for the density. It all depends on if it's solid stud or it's open stud. So meaning like, do you have like a 2x6 at the top on a slant and then rafters down below, and then there's space in between for the cellulose to go? Or is it, that's kind of like where the challenge is. If you just put your tube in and filled it up and were just, listening to a podcast and weren't paying attention, you wouldn't have any density. But if you had the dense tube in to where it needed to go, and then it was backing up as you go along, and you knew that where the tube was going, it was packing, then you'd have confidence that it was packed. So it's a challenge, but it's also a quality assurance kind of thing. Like open up, take a density sample, like tell them you're going to look. If I was blowing the ceiling and I was taking down the ceiling and putting up an air barrier, I would have confidence that I can touch and feel it and know that it felt like a firm mattress, and then I can open up a hole rather easy and check the compression of it all the way up. There's a method to it.
Right. Okay, great. Thank you so much.
Thanks.
Thanks, David. Next, we have a question from Enrique. Hi, Enrique. Happy New Year.
Hi, Sharon. Thank you very much. I'm Mark. Thank you, Kevin. It was a great presentation. I just want to ask what is a good brand for inexpensive loose blown cellulose to blown in the attic? I just have, I know that the Home Depot rents those, but this is an overseas project and I don't have a chance to rent it anywhere. So I'm gonna have to buy it here and ship it there. So it's only 27 houses. It's the area is 530 square feet, 9 inches of cellulose. So it's like 20 bags of the sanctuary per house. So I can do a house per day. I don't need to do more. So it's a low volume, inexpensive thing. So I don't want to spend $10,000 in a machine. So
Yeah, I wouldn't spend $10,000 on a machine either. I'd keep my eye on, for loose fill. Honestly, you don't need a big fancy machine. You can get like a regular decent machine, especially if you're only doing 20 bags a day is your production goal.
Yeah.
You could get away with a smaller machine, even a used machine, it just that's been tuned up, and then ship that over.
What's a good brand?
Crendel, Cool Machine, Accu, Infotech. You know, you're in Vermont.
Yeah, but this is going to South America.
South America.
I would have to ship it from Miami or something.
Yeah, I mean, you could. There's some people sell some of the installation machine manufacturers sell used machines as well. So they might have a machine to be able to like sell you. You know, like it depends if the machine's worth sending back to. You know, like if it's. You know, like if somebody could use it there, is there a market for it? You know, like to just leave it there.
Yeah. So any brand would do the job.
Most of 20 bags a day. You don't need a big heavy duty machine. You can get away.
No, it's the same like the ones Home Depot rents, but
yeah,
something like that.
I would yeah.
I tried to get a brand from the Sanctuary people from Green Fiber, but they don't. I mean, they don't make them. They don't supply them either. So
yeah, I would check some of the, just see what's out there on Craigslist and buy a used machine and see if you can get it over there. And then product wise, any of the best product you can get at the price to be shipped over. I would buy them in pallets just so that they're ready to ship rather than having to load and unload. So palletize, like however many you might need.
Yeah, you will buy them in pallets in a container. Yeah.
Yeah. So that to me, that would be setting up with whoever you're buying from. Will they sell you a half trailer or a full trailer, and palletized to send over? Because they pack the trailers. They pack the regular cargo trailers most of the time. The tractor trailers, the 42 foots. They either pack them full or half, and then they send them on their way. I think you would have to send them the container and then pack it and then pick it up.
Yeah, that's the idea, is to sell them a 20-foot container. Yes, there.
I would also reach out to a few of the other manufacturers, see if they have a machine laying around.
Okay.
They want to offload to a good cause, So.
Thank you.
Excellent advice. Thank you, Enrique. And next, Kevin, we've got somebody not too far from you in New York City, I believe. Ravi, is this the Ravi I know from Plain Remodeling? I think you're muted.
Indeed it is. Thank you, Shannon. And thank you, Kevin. I've received rave reviews from my colleague, Christina, who I think attended your the Firehouse tour. Also at 475, we were there today, and they were talking you up. So your reputation precedes you. My question, I think you sort of addressed it, is how do you typically deal with service cavities? Because pipes leak, wiring shorts, it's installed incorrectly, you need to go in there, fix some things, you want regularly accessible cavities for typical repairs. What are the details that you are seeing very commonly for dealing with service cavities?
So we normally don't insulate service cavities. So we have our air barrier, insulation goes behind the air barrier, and then especially in brownstones and things like that. So then we don't go back and dense pack the 2-inch space of the service cavity because we don't need the R value. But also good practice just to keep it clean and easy and accessible. So we don't insulate those spaces unless it's like a critical detail where we need the extra R value. So normally we make that R value up on the roof, and then the passive house consultant will tell us if we need extra R values somewhere, or we need to, if something changed. So service cavities are normally uninsulated, and then it's normally an easy, simple drywall repair. Either plywood, if the air barrier is plywood or the air barrier is a membrane, nothing should get harmed or wet or anything like that. You have a water leak that bypasses and gets beyond the air barrier. It's a simple method of just cleaning it out, cutting open the air barrier, drying it out, getting rid of the wet material, like any fiberglass, cellulose, rock wool, any insulation that's wet, you get rid of it and you replace it as if you would need.
Got it. Thank you.
Cool.
Thanks, Robbie. Great to see you. Mark, I think you've got a question.
I could go forever. This is fantastic. Kevin, I was hoping you were going for the 4-hour mark. I wasn't kidding on the front end. You also had me laughing a couple times. So first and foremost, when you cover, for my listening, the technical and the technique and the technology, it's always a couple screw turns more than what you've delivered before. So I appreciate it. But then today you gave your tip to the trades, your tip to how to get it done, your tool usage, your manufacturer usage, and all the ones that you don't use. So I think that is so informative. But we also know, a lot of us know you as someone that does the blower doors as well. So while today, obviously the focus is the cellulose, if you are given the task of putting the blower door guy's hat on and you're sent to a job, and what is your approach then? So if it's not insulated yet and you have the chance to air seal, but what about the other folks out there that don't have your knowledge and have to apply that? Now they're just insulating, but it's not tested for air seal. What is your thought on that?
On our projects, when we do the air barrier, we test before we blow, just to know where we're at. And it helps us find all the little leaks. Like there was that one video I showed where it was blowing out. It helped us find a seam. That's helpful. If a good team installing an air barrier shouldn't really, like it happens, but you should be able to, it shouldn't be there really. And then we do see some reduction once the cellulose goes in, because there are some really tricky areas that sometimes you're never going to really get your eyes on ever again after it's been framed and onto. So if ideally from an idealistic point of view, like do a blower door before and a blower door after, and then when the windows go in, like a staged blower door. But just the process of running a blower door and doing blown in cellulose is great. If you own a house that isn't passive house and it has no insulation or limited areas insulation, dense pack cellulose acts as close to an air barrier as you can get. In weatherization, we would take our blower door number and cut it in half just by dense packing the sidewall and doing some regular attic air sealing, and we would see that blower door number drop. So there's a lot of potential there, and cellulose is a great product to stuff those areas if you can't access them and open them up.
That's why I asked the question. It's that added air tightness that you not only test for, but perform. So thanks so much for your work and for passing it on to the rest of the industry, Kevin. You're awesome.
Thanks, man.
As you said earlier, Kevin, blow it up and fill it fat with a double pH. Yep. Last questions that I have tonight, except for the additional one that just came in from Barbara that I almost missed. Eric Rem. Eric, would you like to come on and ask your question?
Sure. I asked this question in chat and got a lot of good answers already, but I kind of wanted to throw it out there, which is imagine a single-story house, a vented, unconditioned crawl space, because that's what works in Oregon and in the Northwest. And we want to blow it underneath the floor. So underneath the floor joist. So it's not a slab on grade, it's a unconditioned short crawl space. So the reason I asked that question is insulation is just insulation. It also plays a role in moisture transport. So I wondered if there were any concerns about that. One comment that I got was, block out the areas that have wet things above. That makes a lot of sense. I hadn't even thought about it, but I'm more worried about the wet things coming up from below. It won't be like a muddy crawl space, it'll have a vapor barrier and gravel and a vapor barrier over it. But I wondered if there were any concerns and also any recommendations as to whether this should be done netted or with OSB or with some rigid foam, which I'm trying to stay away from.
It's a little bit of a catch-22 because if you're insulating the underfloor of a house over a crawl space, you should really try and mitigate the thermal bridge somehow. So either like continuous insulation underneath it. Like I would consider maybe like rock wool in the the board form, and then put a vapor barrier and air barrier over that. Or if you wanted to go the rigid foam board way, or maybe the zip bar or something of that matter, and then dense pack it. If you're putting down, for my money, if you're putting down a vapor barrier, normally what I would do is insulate the walls of the crawl space, the surface areas, a lot of time much less, and it's a lot more affordable to do the four walls as opposed to the whole floor. A 3-foot stem wall by the perimeter is a lot less square footage than the entire footprint of the house. That's normally my recommendation on crawl spaces. But if for just cold floors or warm floors, or trying to, whatever your reason is, you really want to have either some sort of air barrier, vapor barrier, or something to stop the vapor transport from down below to up, but you also don't want to trap anything in the floor area. So one of the intelligent membranes would probably go a long way. It's just there would be like a lost opportunity if you didn't mitigate that thermal bridge somehow. So maybe a furring strip going 24 on center the opposite way, and then run your membrane and then blow it. It's almost like almost like a double stud, but you only have a thermal bridge at the cross, not the whole stud. Maybe something to do. We're doing one project for a friend in like a cathedral ceiling that's like an 8-inch cathedral ceiling, and then we're running 2x4s the opposite way, and then putting up a membrane and then going the other way. So instead of having a continuous thermal bridge of a psi value, we have chi values of the point thermal bridges at each location. So
Thanks.
And 548, and he dives into like details of thermal bridges. This guy just doesn't stop.
I know.
Hey.
I'm ready to put up the paywall, Sean, so that
Yeah.
we can just start. He can start charging for this.
Totally. Hey, Eric, just on that note too, just remember that the plywood on the sheathing is your vapor control layer, because that's the warm side of the floor. So really, if you're going to put a membrane down, you almost want to treat the bottom side of that floor like a WRB membrane. But realistically, what Kevin said with the amount of amazing knowledge he's passed on today is, cost wise, insulate the foundation, don't insulate the floor, because you're just getting tricky with what you're doing there.
Absolutely. When you have a choice, right?
I've had a very similar scenario where I built an addition with a floor just about 6 to 8 inches above the outside ground. And I had hydrothermal analysis done on that. And out came that is very little to worry with regard to moisture coming up from the floor. And so I built it exactly as Sean said. Plywood was on top and the floors, and then I used the wood fiber board underneath it and vapor open to the outside, because the main vapor drive still goes from up to down. Yeah, and then it is fully ventilated underneath, and that's the key. So if the basement was really wet, then, or the crawl space, then there's probably more issues there.
Good point with the venting too.
Thank you.
Yeah. All right, Carolyn Moss, are you with us still? Carolyn? Would you like to
Hello.
unmute?
Am I unmuted? I think I am.
Yep.
Okay, I can't see that I'm on, but anyhow, I have a few questions. First one, do you need to have a place for the air that's in the cavity to come out so you can blow the cellulose in?
What's the cavity? Is it plywood? Is it a membrane? Is it drywall?
So if you have well, we're looking at a double stud wall, quite a deep double stud wall, 16 inches. And then, 24 feet long, 9 feet high. So first of all, do you need to section that wall off so that you can get it packed tighter? And then, like I said, do you need a place for the air to come that's in the wall to come out so you can get your insulation in?
So making slits at the bottom is an old school way of doing cellulose. It's like, we need to, it was when they did it with poly and the machines didn't have a lot of pressure. Fluid dynamics is fluid dynamics, path of least resistance is path of least resistance. So you don't need to make those slits. You just need to make sure that your nozzle is deep down into where it needs to go. And that the nozzle is not too big, right? So you can't use a 3-inch nozzle and expect it to push 12 inches. So you would need to have like closer to 2 inches or 1.5 inches to make sure. So when I do larger cavities, like a double stud wall, it's a 2-pass process. It's a loose fill with a 3-inch as fast as I possibly can. And then it's a go back and pressure pack with either the needle or the dense pack tube to get that extra oomph and push in those areas. And if you had a perfect world where you could section off every stud, every bay with netting, that is an added bonus. So then you don't have to have a smaller tube. You can go with a bigger tube.
So to net off each, like between the two studs, you net it off so you can.
It's a luxury. It's like, oh, I'm going to get extra value here. It's not a necessity. So if I was doing it and I had membranes, I would use my 8-foot insulation needle, and I would just start from left to right, and I wouldn't, because I have the hard pipe going to the bottom, and I know that it's packed, and I pressurized it all the way up, and I went left, bottom right, bottom left, bottom right, and I went back and forth. I wouldn't feel that I need the full netting. If I was just using a regular 3-inch or 2-inch cellulose flexible tube and put it down the bottom and let it whip around, then I would want the netting.
All right, great. Thanks very much.
No problem.
I took
Good
notes
luck.
that time.
Pressure is your friend. So set the pressure on your machine as high as you can go, and just check and touch and feel. I would do a few mock-ups and like density check walls, one with the netting, one without the netting, and see which process works best for you before you get into the actual building. So.
Perfect. I think we're in the rapid fire round now. It's 8:53 and we still have a few folks left in the queue. Dan Levy, would you like to unmute and ask your question?
Yes, I would.
Did you move successfully, Dan?
Yes, I am now. I have a real problem with attending Passive House Accelerator now. I am in an 1851 timber frame, and 2 stories below me is a fantastic craft brewery where it's better than Cheers. Everyone really does know my name. And it has energy recovery ventilation. So, and I know where the inputs and outputs are, so I know where to sit. So you guys are making life very complicated, but we're out of time. So
what's the name of the bar? What's the name of the brewery?
It's the Rojan Brewery. That's a shorthand for one of the settlers here in the 1700s. This is Hillsdale, New York. And I recommend it highly. And it's Steve Bluestone, who some of you, especially New Yorkers, would know. He's a 3rd generation New York City developer, and he was building large scale passive house buildings at about 0.5% over their conventional costs. So I am thrilled to be here. And of course, I'll be starting a passive house project on the main street in the middle of Hillsdale, but I'm babbling too much. So
no, I think you have our next roadshow destination, Passive House Trade,
Absolutely,
Passive
yes.
House Tech Tuesday from the bar.
Exactly. A tour of autoclaved area concrete buildings at Meet Passive House and a bar. Yes.
Fresh air and fresh beer.
So the question that I have is, my son owns a home built in 1923 in Shaker Heights, Ohio, which about half of it still has the ball and tube, knob and tube wiring in place. And I've always understood we need to just rewire that whole building, which is really complicated because it has all of the historic details are entirely intact. And then I've read other claims that it's perfectly safe and you can even insulate it. And I have my doubts. Any experience with that?
So I've never run into it in my practice in New York City. As an energy auditor in New Jersey, I ran into it a few times. And then in the walls, it wasn't an issue. In the attics, it was always an issue. So if it was ever in the attics, it needed to be come out. The benefit of it, Dan, is if you are taking it out, salvage it and sell the porcelain and the knobs.
Yes,
People
yes,
buy them
that's
on.
good advice. Dan, I don't think you're going to be able to insure the building from an electrical standpoint. So maybe a call to the insurance agent first will answer that question. But Kevin, yes, those porcelain pieces are collectible.
Thank you. And I forgot to say, Kevin, that was a fantastic presentation. I have done dense packing in the days before you could find a contractor that knew what it was. And I'd rather not do it again, but I was really thrilled when I finished.
Yeah, it's a messy job, but somebody's got to do it.
All right, well, up next is Abby, who is going to be a guest soon and is still here with us at this late hour. Abby, come on, ask your question.
Hi there. I just wanted to pick up on a comment Kevin made about the fire resistant properties and how, you know, there's an assembly where you can use it as a demising wall. I didn't catch the name of the manufacturer. I was wondering if you could just revisit that quick. Take notes. I'm looking at a low carbon building. So, you know, anywhere we can replace extra layers of sheathing gyp with cellulose would be awesome.
The manufacturer is New Wool.
New Wool.
It's NUWOOL. And if you go on their website and you look, it should be, let me see if I can find it. Products, benefits, specification. Might be in one of their technical documents. I can't find it right now, but it's New Wool, and
Sure. Yeah, I found New Wool, the website. Thank you. That's good. I can search from there.
Yeah, sorry.
Thanks, Abby. And you know what, Kevin, while you're naming names, Patricia wanted to know the 6 cellulose brands available in New York.
Is New Wool? It's available, but you have to special order. Nobody stocks it. Most cellulose is bought contractor to manufacturer.
Now, my question was, you showed a picture of 6 different types of cellulose that were available at the beginning of your presentation. That was the question. What were those 6?
Those 6. So Igloo from Montreal, Green Fiber, Sanctuary, and the rest of them are available in all major markets. New Will is from Wisconsin, I believe. And then Soprema is from Canada and handled through some distributors. And then I think that's it. And then there's a new one on the market. It's called Clean Fiber, and they're in Buffalo, I believe. So they're probably your most local source cellulose. Clean Fiber.
In Buffalo, what was it? How do you spell it?
Clean, CLEAN, fiber.
Great. Thank you, Kevin. Patricia's been super patient with me in the chat. Thank you, Patricia. And our last question of the night is from Rodrigo. Rodrigo, are you still with us? Your Spanish is better than my English, Rodrigo.
I'm sure. First, Kevin, thank you for your presentation. It's amazing. And My question is from passive house code or building. If you have experience in prefab stud or wood stud building, just imagine a 12 by 2 stud just from cellulose. How you know is free thermal breach insulation system in the construction. I explained well. Sorry
2
for
by
my
12
English.
wood studs, and is there a thermal bridge?
Yes, there is.
Yeah.
So commonly they use I-joist in that situation, or they'll do a 2 by 12 I-joist that'll have a reduced thermal bridge, or they'll do a Larson truss, or they will do sheathing that is wood fiber or insulation, or they can do some product that's made by U.S. engineered woods, I believe. It's a T-stud.
Yeah, it's a T-stud. Great. Well,
But
if anybody
The more
has-
common prefab is a 2 by 12 and then like a Agapon Gutex or something over the top of it, or some sort of insulated sheathing.
It's outside. You
Yeah.
need extra insulation outside.
Yep. So I went to a panelized factory in BC. I forget. They did the Whistler House. Sean, you would know. BC Passive, I believe, is the name of their company, and they did a 3/4 inch thing of Agapon outside, which is wood fiber,
right,
and then solid 2 by 12s or 2 by 10s, and then they blew it in dense pack with like a long needle.
Just from external insulation is just for thermal breach free. You know,
Yes.
is
Yep.
okay. Apologize for my English. Sorry.
It's all right.
Hey, and all good, Rodrigo. And you need to check out the the Icebox Challenge that happened in Santiago that had CLT and wool from Patagonia on their passive house icebox, and it was local wool from the local sheep. So check that out. I think that could work out quite well for you.
Oh, perfect. No problem. Good.
Thanks for joining us.
Let me send you our information. We have a little bit experience in passive house in our local weather.
Yeah, and if you haven't seen the new issue of Passive House Accelerator magazine, it's all about going south with Passive House.
Yeah.
So
Yeah.
yeah.
Yep. Yep.
And I just reminded everybody in the chat, if you don't know, this whole presentation is going to be up online next week. So you can watch it again. You can take some screenshots and see what the names of the cellulose are in every image. And you can also save the chat by grabbing those 3 little buttons at the bottom of the chat window saying save chat and then show in folder. And you will get a text file of all the comments, all the answers, and maybe even the names of some of your new friends. So thanks for joining us. Happy New Year, everybody. We're excited to have you back. And,
Yeah.
anyone else have any parting comments? for
Oh,
Kevin?
we're not
Yeah,
done
there was
yet.
actually-
We
there
got
was-
traditions.
Can I sneak one last question in?
Go ahead, Al.
I think 2 or 3 had asked it. Maybe it's been answered and I missed it. Is there a point at which these insulation effectiveness actually lowers, like if you go too dense? So let's say you go 5-6 pounds, and then all of a sudden your effectiveness actually goes down.
So it's my understanding that it's at greater than 4.5 pounds per cubic foot, you're not gaining any extra stability, but you're not losing any R value, but you're leaving the profits in the wall kind of thing. So it's diminishing returns.
Yeah.
But it's also it's also like 5-6 pounds is really hard to do, and is it really worth it? Like when I first started dense packing and checking, we were consistently at 5, and we just need to adjust our machines to get it better. But my theory was I'd rather pack it tighter and not have it settle and get a call back until we can get it lower. And now we're closer to like 4.5. That's like our regular benchmark of where we want to be. When I start seeing 3.5, 3.2, I'm a little nervous. I'm like, what's going on, guys? You know, like we're close to our threshold. And then we do evaluate, touch and feel. But air is the insulator. So the more dense it's packed in, it's just smaller cavities of air. I don't think it reduces the R value. I am a little concerned over I'm always concerned when somebody says that the R value is greater all of a sudden because the manufacturer of fiberglass. There's something happened over the past 10 years where fiberglass manufacturers are saying that they get R19 out of 5.5-inch walls.
Yeah, I've been recently getting a lot of comments too, saying that dense pack fiberglass is better than dense packed cellulose, and I don't believe that either.
I don't have a problem with dense pack fiberglass. I have a problem with the price of dense pack fiberglass. It just doesn't compete with actual cellulose. You know, like a 30-pound bag is $42. A 25-pound bag of cellulose is $12. You know, like they don't match up. You know, like granted, you have to blow the fiberglass at 2 pounds per cubic foot and the cellulose at 3.5, but the cost difference I don't get it. It's just as good. It comes out it's just not as dusty. It's kind of like when somebody tells me they prefer the fiberglass, it's just that they don't like getting dirty and they don't like the dust, which is fine. That's why we wear our masks and our suits and everything. But for the cost for the customer and, you know, the machinery, it's not there. Like, I really did enjoy blowing the Gutex. I think blowing Gutex, if we can get Maine up and running with their wood fiber kind of like product, blowing the Gutex at 2.2 pounds per cubic foot was really nice. And it was relatively dust free. It wasn't too crazy. I enjoyed doing that at 4.
Was it heavier?
The product is heavier, but it goes in at a smaller density.
Right.
So it feels different. It feels lighter, but it's more similar to blowing in fiberglass. Whereas blowing in rock wool is greater density. It's 4 pounds per cubic foot. You know, is the benchmark there. So
yeah, it's interesting. You got to get your structural engineer involved at some point. Hey, I got a direct message question from Mike Lind. He asked, is there a way to insulate a conditioned attic between the rafters without netting using adhesive? I don't know what this means. Maybe you can enlighten me.
No, there's no way to do that.
Okay.
Adhesive?
I've never heard of it. Yeah. Mike, I'm sorry, the answer apparently isn't it.
Well, I've seen a demonstration here of wet blown. But this was into regular walls.
Yes.
You can open blow and then they spray the adhesive while that's being blown, but not overhead.
What's the adhesive? It sounds sticky and toxic.
Yeah. So both some of like the Certainty, the Sanctuary, and some of them else, they have a wet spray method where you add water and maybe some glue and it'll stick and you can scrub it down. I personally am not a big fan of doing that with cellulose because of the ability to hold on moisture in a conditioned house, like somebody that lives there. But new construction, if I can run a dehumidifier and dry it out, I'd give it a shot. But I do like the wet spray. I haven't sold it to anyone recently. It's just when they're used to paying 40 cents per square foot for fiberglass and we have to charge whatever $1.25 for wet spray to install it perfectly, you know, it's a non-comparison. So but insulating perfectly is insulating perfectly. Insulating poorly is insulating poorly.
Those are good words to live by and good words to end on, Kevin. Thank you so much. You have not only gone through the overtime, but you've gone over the overtime. So another round of applause. Thank you for kicking off our 2022 so beautifully.
Thank you.
with that, I think we're ready to say goodnight to everybody. Any parting words, Mark, Sean,
I
Kevin?
think we need to change our virtual backgrounds real quick for a little tradition. Don't you, Shannon? Come on, Kevin's already smiling.
I can make this happen. Let's see.
All right.
Do I still have my background? I do.
Shannon, right now you look like a house with beautiful landscaping, but we know what you look like. Kevin has the best background. I'm going to get in trouble for mine. Sean's green screen is broken. Part of BC is not allowing green screens right now, so we're just dealing with that. And Shannon has her up. So Kevin, you start, you pass it over because you are the king of the 3 T's tonight, brother.
All right. Passive House Accelerator, construction tech, technical, technique, technology. And I'm going to kick it to my man, Norm.
Passive House Accelerator, construction tech, technical, technique, and technology.
Who's it going to, Norm?
Oh, geez. Okay, trial by fire. Let's go to Rodrigo.
Nice.
Rodrigo, you are on. First, you want to
Really?
read this side. And then you want to read this side.
Thank you, guys. For me, it's an amazing moment because it's the first moment I meet with you, and I want to share our experience in Chile, in South America. Not really all Patagonia. We are all weather. We have desert. We are Mediterranean weather, and so cold weather in the south. We have an amazing country, and the passive house building construction is super interesting for us, and we're so interested to share with you our experience. Thank you very much for this moment.
Thank you.
Thank you, Rodrigo. And we are going to throw it to Barbara and Oz.
Okay, Passive House Accelerator, construction tech, technical, technique, technology, Tuesdays, but it's Wednesday here, but that's all right. So toss it to Abby if she's still on.
Oh, geez. I didn't know this was a thing. Passive House Accelerator, construction tech, technical, technique, technology.
Who are you going to pass it to, Abby?
Let's say Tony Doust.
You think he's on a boat? Try to pick someone that has their video running.
Yeah, he's in the middle of the Pacific at the moment.
Oh, darn.
In between
Let's go to Eric Rim.
All right, Eric.
There you go. Thanks, Abby.
Yeah.
Eric, are you there?
I am. I asked my question earlier about the crawl space.
Yes, you've been called on. I don't know if you can see your screen. You've been called on to help us echo the message by reading this side. And
Read the
then
background, Eric, over Kevin, Shannon, and my shoulder. Just read the background, brother.
Okay, so what is it that you'd like me to do?
You'll read the words Passive House Accelerator, construction tech, and then you'll say technical, technique, technology, and then call on someone else to do it next.
Okay, so it's like a popcorn thing. All right, Passive House Accelerator, construction tech, technique, technical, and technology. And I'm going to popcorn over to Frankie Fela.
Play the popcorn game, Frankie.
I love it. Frankie, are you with us?
Frankie's not, but I am.
Hi.
Hey.
What's up?
Not much. I've been here the whole time. I've just been busy, but really good talk, Kevin. Good job. And this was awesome.
See, Amy, you know what we're doing, right?
Yes, Passive House Accelerator, construction tech, technical, technique, technology.
Can you do it again, Amy, but do it in Frankie's voice?
I can. Might be mean though.
Don't do it.
Yeah.
We're encouraging you. Come on. Blame it on us.
Mark, Frankie's my friend.
I know.
Oh, I have to call on someone.
Yes. Well done.
Did Peter go yet?
No, Peter did not go yet.
Thanks, Amy.
He's muted. There we go.
Not yet. Passive House Accelerator Construction Technical Technique Technology. That's a wonderful presentation, Kevin. Thanks.
Thanks, Peter. I think we can end it on that. What do you guys think?
We'll see you all next week. Thank you, Kevin.
Thanks, guys.